In this video, we are going to be starting to explore exponent rules. So at the end of this video, you'll be able to simplify expressions using exponent rules. Okay, the first thing that we're going to do before we start actually looking at exponent rules is just kind of dealing with what is an exponent and what does it mean. An exponent, if you remember, is just a power. And so we're going to be dealing with powers of 2, and then powers of 3, and then powers of 5. And then we will also be looking at powers of x and actually starting to get into our exponent rules. So first of all, hopefully we know that 2 to the first power just means there's 1 2, so my answer is going to be 2. All right, let's say I wanted to multiply by 1 more 2. So instead of multiplying by 1 2, I want to multiply by 1 more 2. So I'd be multiplying by 2 2s, and then 2 times 2 is simply 4. All right, let's say I wanted to multiply by another 2. So I'm going to multiply by 3 2s this time. So if I multiply 4 by 1 more 2, I'm going to get 8. Right, and then if I am at 2 to the third and I want to multiply by 1 more 2, that would be 2 to the fourth now. And if I multiply by 8 by 1 more 2, I'm going to get 16. And I'm just going to be continuing this table. If I multiply by 1 more 2, that would mean now I'm multiplying by 5 2s. And multiplying 16 by 2 will give me 32. And then the next one, if I multiply by 1 more 2, I'll now have 6 2s. 32 times 2 is 64. The next time, if I multiply by another 2, I'm going to get 2 to the 7th. And multiplying 64 times 2, I'm going to get 128. And then if I multiply by 1 more 2, I'll get 2 to the 8th. And 128 times 2 is 256. So you'll notice every time I multiply by 1 more 2, the power goes up 1. And I'm just going to do just a couple things. So if I'm at 2 to the 3, and remember when I said if I multiplied by 1 more 2, I ended up being at 2 to the 4th. Right? If I was at 2 to the 2 and I added, instead of adding just 1 more 3, let's say I added 3 more 2s. So if I was at 2 to the 2 and I added 1, 2, 3 more 2s, notice I am now at 2 to the 5th. All right, if I was at 2 to the 7th and I just multiplied by 1 more 2, I would be at 2 to the 8th. And really what these mean, if you want to think about it, 2 to the third, remember that would mean I just multiplied by 3 2s, and then I multiplied by 1 more 2. So notice I do have 4 2s, that's why it does equal 2 to the 4th. And here if I had 2 to the 2, I had 2 2s, and then I multiplied by 3 more 2s, and then I ended up with 2 to the 5th. And if I was at 2 to the 7th, so I had 7 2s, and I multiplied by 1 more 2, I would end up being at 2 to the 8th because I now have 8 2s. So if you're looking at, if you just kind of look at the pattern, it just makes sense. But then also now if you look at my exponents, I had 2 to the third, and then I actually added 1 more 2. So there's an invisible 1 right there, and that ended up being 4. And then you'll notice if I had 2 2s and I added 3 more 2s, I'm now at 2 to the 5th. And if I had 7 2s and I added 1 more 2, I'm at 2 to the 8th. So we actually are just discovering our exponent rules. So I'm going to be doing that same thing with 3. We won't go it quite as in depth. So if I had 3 to the 1, which would just be 3, if I multiply by 1 more 2, that would be, excuse me, not 2s this time, 3s, I'd be at 3 to the second, and 3 times 3 would just be 9. And then if I multiplied by 1 more 2, I'd have 3 to the 3. 9 times 3 is 27. And so again, if I had that, I'd have, I'm just going to make up a few things. If I had just, if I started at 3 to the 1 and I added 1 more 2, I would now, so if I was at 3 to the 1 and I bumped up 1 more 2, I'd now be at 3 to the second. If I was at 3, let's say I was at 3 to the 2 and I multiplied by 1 more 2, I was at 3 to the 2 and I multiplied by 1 more 2, I would now be at 3 to the 3. And again, notice if you're adding the exponents, 2 plus 1 is just 3. And then if I started at 3 to the 1 and I added 2 more 3s, excuse me, stuck in those 2s and 3s, and I was at 3 to the 1, I multiplied by 2 more 3s. Notice I'm now at 3 to the 3. And again, you'll notice we can just add the exponents to actually get that when we're going through the answer. All right, so let's take a look. Same thing if I'm dealing with 5s. If I'm at 5 to the 1, I'm going to start with 5. And then if I multiplied by another 5, that's now 2 5s. 5 times 5 is 25. And then if I multiplied by 5 one more time, I'd be at 5 to the third. And 25 times 5 is 125. Okay, I'm going to do something a little bit differently with this one. So let's say I was at 5 and I wanted to multiply by 5, and then I wanted to multiply by 5. So let's just see where that would give you. I was at 5, I multiplied by 5, and then I multiplied by 5 did again. So notice it gives me 5 to the third. And if I look at those exponents, notice just by adding those exponents, I would get 5 to the third. Let's try one more example like that. Let's say I had 5 to the second times one more 5. So if I was at 5 to the second and I multiplied by just one more 5, that is going to give me 5 to the third. And then again, notice that getting that same way would be just adding my exponents. All right, so now let's transfer over to x's. Actually, I'm going to go back to my 2 page for just a second because I want to do a little bit more since we have a little bit more with this. There are several different ways that I could do. I could multiply by things. A couple things that I could do that would mean the same thing. If I had 2 to the second times 2, all right, I was at 2 to the second and I bumped up 1, 2, I'd now be at 2 to the third. Is there another way of writing that? I'm going to say yes, there is. If I had 2 and then I multiplied by 2 and then I multiplied by 2 again, so I was at 1, I multiplied by another 2 and I multiplied by another 2. Notice that still gets me to 2 to the third. And again, these all have invisible ones on them, so I'm really following my same thing while we're adding those exponents. So let's say I would like to end up getting 2 to the 6th. I'm going to write one way that I could get 2 to the 6th. I could have started at 2 to the 4 and then multiplied by 2 more 2s. So I could have multiplied by 2 to the second and I would get 2 to the 6th. Would you take a minute and see if you can come up with maybe 3 more different ways that you could find 2 to the 6th? So just pause the video a second and see if you can come up with a few different ways. All right, welcome back. Hopefully you've written down a few ways. I'm going to write down a few and let's just see if you ended up writing down any that I did. How about 2 to the second? And then I bumped up 2 2s and then I multiplied by 2 more 2s. So I did 2 to the second times 2 to the second, and then I ended up with 2 to the 6th. A couple other ways, I could have done 2 to the 4th and then multiplied by 2 and then multiplied by another 2. That would give me 2 to the 6th, and notice those are really invisible ones on them. So if I add my exponents, I still get 2 to the 6th. And then let me just try one more. Let's say I had maybe 2 to the third, and then I multiplied by 2 more 2s, and then I multiplied by another 2. That would also give me 2 to the 6th. And notice again, we could just do that by adding my exponents. But another way I could do it is I had 3 2s, and then I multiplied by 2 more 2s, and then I multiplied by 1 more 2, and now notice I do have 6 2s. All right, so now I'm going to jump to the example with my x to the first power. So if I have x to the first power, we know that that is, there's really not much of x, and then my next one would be x squared, and my next one would be x cubed, and those tables are just going to look the same. So here, if I started with x to the 1, and I bumped up an x, notice if I'm at x to the 1, I multiplied by another x, I get x to the 2. So notice the pattern still holds. I'm just adding those exponents. So if I'm at x and I multiply by x to the 2, so if I'm at x to the 1 and I bump up 2 x's, notice it does give me 2 x to the 3, and 1 plus 2 does give me 3. And again, really what this is saying is that I had 1 x and then I multiplied by 2 more x's, and now I have 3 x's, which is exactly what that shows. The property that I'm using right now, just in case you would like to see a generalization of it, is going to be x to the a times x to the b. And basically what we're doing, we're just adding those exponents. So this would actually be x to the a plus b. All right, but we can just totally use our common sense. We don't really need to memorize a formula as we do this. All right, I'm going to be doing a few more examples before we finish filling in our tables. So let's say I have 5 to the 3 times 5 to the a is equal to 5 to the 9th. And I would like to figure out what would a have to equal. Well, if I look at this, I know that if I'm already at 3 5s and I have to multiply by some more 5s to get up to 5 to the 9th, the a is going to have to be 6, because 3 plus 6 would then give me 9. All right, let's try another one. Let's say I have 2 to the 4 times 2 to the 6 is equal to 2 to the b, and I would like to know what b is. Hopefully as we're working through these examples, you're just writing it down while I'm writing the problem. So if I have this, I know that I'm at 4 2s. I'm going to multiply by 6 more 2s, and that is going to get me to the 10th power. And again, if you were not sure, you could write out 4 2s, write out 6 more 2s, and then you'll notice we ended up with 10 2s. All right, let's say I have x to the c times x to the 5 is equal to x to the 9. Here, if I look at it, we're looking for c. And I notice, I don't know where I'm starting, but if I bump up 5 x's, I need to end up with 9 of them. So again, I'm going to notice that my c is going to have to be 4 because 4 plus 5 will give me that 9. All right, and my last one I'm going to do for this part of it, we'll have 3 to the 4th times 3 to the d is equal to 3 to the 11, and I would like to find out what my d is. The biggest thing on this one is don't forget that this 3 actually has a 1 on it because there is 1 3 there. So if I look at it, I already have 5 3s. I'm going to have to multiply by 6 more 3s to get 3 to the 11th. So d would equal 6 in this case. And I'm actually going to do one more problem here. If I have 2 to the 7 times 2 to the e, I guess we'll make it, I want to end up getting 2 to the 4. So if you look at this, this is kind of getting us ready for the next thing that I'm going to talk about. What would my e have to be in order to get 2 to the 4? Well, if you'll notice, I'm at 7. I'd actually have to bump down 3 2's to get to 2 to the 4. So actually, e will be -3. So when we're going up on the table, we will add our exponents, and when it ends up being negative, we will subtract those exponents. All right, so now I'm going to have you go back to the table with the 2's on it, and we're going to try to finish filling in this table to see what happens when we have negatives. All right, so you will notice if I started up, if I was at 2 to the 8th, and I look at my 256, to get from 256 back down to 128, I'd have to divide by a 2. So to get from 2 to the 8th to 2 to the 7th, I'm going to be dividing. And then to get from 2 to the 7th to 2 to the 6th, I will be dividing. So notice each time, 128 divided by 2 is 64. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 4 is 8 divided by 2 is 4. 4 divided by 2 is 2. So if I'm going this way, we are going to be dividing or subtracting the powers. All right, so here, if I'm at 2 to the 1 and I bump down a power, so I'm going to get rid of one of those 2's, 2 divided by 2 is going to be 1. And I'm guessing you did not realize that if you take something to the 0 power, you'll get 1, but that just kind of is how it works out. All right, now let's go down. If I went and subtracted another 2, it's going to be 2 to the -1. And again, I'm going to take the 1 and I'm going to divide it by 2. 1 divided by 2 is 1/2. Or another way you could think of it is cutting 1 in half. Right? The next one would be 2 to the -2. 1/2 cut in half would be 1/4. And then 2 to the -3. Again, I'm just working down a power each time. Cutting 1/4 in half would be 1/8. And basically what we are doing there is we are just continuing to cut in half, and we are reducing those powers. And one thing that I would like you to notice is, like, if I have 2 to the 2, and notice that gave me 4. 2 to the -2 ended up giving me 1/4. And I just want to show you the reason like that would work that way. If I have 2 to the -2, we're basically starting with 1, because we're going to start with this is kind of my middle of my chart. So I'm starting with 1. And 2 to the -2 means instead of multiplying by 2 2's, we need to divide by 2 2's. And 1 divided by 2 divided by 2 would be 1 divided by 2 2's. All right, if I had 2 to the -3, we're going to start at 1, and then instead of multiplying by 3 2's, we are going to divide by 3 2's. So the way that would look, we're going to have 1, and we're going to divide by 3 2's. So 2 to the -3 is actually equal to 1 over 2 to the 3rd power. Okay, let's go to our 3's and just do that same thing. So we know 3 to the 0. 3 divided by 3 is 1. 3 to the -1. 1 divided by 3 is 1/3. And 3 to the -2. Again, I'm just moving down my powers. 1 divided by 3 is 1/9. And again, just recapping, if I had 3 to the -2 here, we start at that base of 1. And then instead of multiplying by 3 2 times, we're going to divide by 3 2 times. And notice that gives me 1 divided by 2 3's, excuse me. For my 5, same thing. If I have 5 to the 0, 5 divided by 5 is 1. So please notice each time, anytime I get something to the 0 power, I do end up always getting 1 just because of what I'm dividing by. Then if I have 5 to the -1, 1 divided by 5 is 1/5. And then 5 to the -2, 1/5 divided by 5 is 1/2. 25th. And again, we'll just do one example for that one. If I have 5 to the negative 1, that means start at my base, which is 1. And then instead of multiplying by 5, we're going to divide by 5. And 1 divided by 5 is that 1/5, which is exactly what's on my chart. Okay, so then if we have our x is now x to the 0, x divided by x is just 1. Then if I bump down a power, x to the negative 1 means 1 divided by x. That's going to be 1 over x. And then x to the negative 2, we're going to divide by another x. So 1 divided by x will be 1 over x squared. So as an example, not even one that's on the chart, excuse me, if I have x to the negative 4, what that means is we're going to start with that middle. We're going to start with the 1. Instead of multiplying by 4, we are going to divide, by x. We're going to divide by x 4 times. And if I do that, notice I have 1 divided by x to the 4th power. So hopefully that helps you understand those negatives a little bit better. Okay, so let's do some examples where we are having to deal with those negatives a little bit. So let's say I have, we'll get into some things that have negatives in just a second, but I'm going to do a few examples with division now, since that's what we've been kind of dealing with. So let's say I have 3 to the 5th over 3 to the 2nd. Remember, when we're dividing, that means we're going back down in the chart. So I was at 3 to the 5th, and I'm going to go back to my chart. I was at 3 to the 5th, which is actually not on there. Make it go on there. And I need to move down. Let's see, what was I? It's going to move down 3, 2. So I'm going to divide by 2 once and twice. Notice that ends up giving me at 3 to the 3rd. Okay, couple ways of looking at this. We were at 5. Since we moved down, we subtracted. So I could simply just subtract those exponents. Or if I really wanted to think about it, writing it outwise, I was multiplying by 5 3's and I divided by 2 3's. So notice 2 of the 3's cancel out and I'm still left with 3 of them. So either way that makes the most sense for you is the way that you should think about it. Let's say I have 2 to the 8th over 2 to the 5th. Okay, again, what this means is I'm at 2 to the 8th. I want to divide by 2 to the 5th. So I'm working down, which means I'm going to go down 5 powers of 2. So thinking about, I could just subtract them. 8 minus 5 would give me 2 to the 3. Okay. Or another way that I could think about it is I was at, I had 8 2's. I wrote 8 of them. And then I divided by 5 2's. So cancel, 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 cancel. Notice I'm left with 3 2's. Whichever makes most sense in your brain is the way that you should work that problem. Okay, so let's do one where it's flip-flopped a little bit. So let's say I have 2 to the 4 over 2 to the 7. Now notice I'm kind of in a bind because there's a bigger number on top. So I'm going to go back to my 2 table just a second here. So notice I'm at 2 to the 4 and I said we need to divide by 2 to the 7th, which means I need to move down 7 spaces. So if I move down 1, 2, 3, 4, 5, 6, 7, please notice that leaves me at 2 to the negative 3. All right, so a couple different ways again that we can think about this. If I did, since I'm moving down, I was just subtracting, 4 minus 7 is negative 3. Okay. Or if I would have, and I'm actually not done with this, and then I'll explain my second way. If I have 2 to the negative 3, we know that that really means 1, and then instead of multiplying by 2 3 times, we're going to divide by 2 3 times. And so this will really end up being 1 divided by 2 to the 3rd power. Whenever we write answers, we will not write them with negative exponents, so that's why I changed it to positive. So now I'm also going to show you if I would have done this the different way. I would have had I'd had 4 2's, and then I would have had 7 2's. And then 1, 2, 2, 2. Notice I end up still having 3 2's on the bottom, and there's nothing on top. And if there's nothing on top, it's really always just being multiplied by 1. So notice that same thing. I end up getting 1 over 2 to the 3rd. Okay. I'm going to do one more example like that with x's. So if I have x to the 3 over x to the, we won't make it too big this time. If I have x to the 3 over x to the 5, again, what we can think about, we're at x to the 3rd. We have to move down 5 x's. So if I move down 5 x's, I was already at 3. That's going to leave me at negative 2. And x to the negative 2, since we're not allowed to have a negative exponent, is really going to be 1. Instead of multiplying by 2 x's, we'll divide by 2 x's. So we'll end up getting 1 over x squared. Or another way of looking at it you had 3 x's and you divided by 5 x's. So after you cancel those out, you'll notice that you have 2 x's left in the bottom. There's nothing that's left on the top, which is really like multiplying by 1. So notice we still get 1 over x squared. You can decide which way in your brain makes the most sense to do that. All right, I'm just going to do a couple more examples. I think I'm going to do 2 more examples. Let's see if I can squeeze a little bit more room in here. It seems like I've run out of slide room. So let's say I have x to the third to the, we'll just do it to the third. Okay, so basically if I have x to the third, that means I'm going to write x to the third 3 times. So this is really like x to the third times x to the third times x to the third. Okay, so if I do that, I have 3 x's and then another 3 x's and then another 3 x's. That is going to give me x to the 9th. And if I have x to the 4 to the 2, please notice that means we're going to write x to the 4th 2 times. So x to the 4th times x to the 4th. And then when you're doing that, if we had 4 x's and then another 4 x's, it's going to leave us with 8 x's. And hopefully you kind of saw a pattern as I was doing that. To get x to the 9th, I could have just taken 3 times the 3 and gotten 9. I could have taken the 4 times the 2 and gotten 8. So whichever way in your brain makes sense, whether you want to write it out or do it another way, that is it. And I'm going to do one more example and then we are going to be done. So if I have x to the 4, y to the 3 to the 2nd, all right, notice this time I have more inside of there, that's okay. So if I have x to the 4, y to the 3 times x to the 4, y to the 3. So this time it's going to be a little bit more complicated, but we got this. Okay, I have 4 x's and then another 4 x's, which is going to give me 8 x's. And then I have 3 y's and then another 3 y's, which is going to give me y to the 6. So then we got it. So then you'll also notice that I could have, in this case, added the 4's to get 8. I could have added the 3's to get 6. So without going through like super formal rules on this, hopefully now you can simplify expressions using exponent rules.